Right, I have 4 competing gate motors. We have the Centurion D5 Smart, we then have the Gemini 12V 12 amp hour, then we have the ET.Nice Drive 500, followed by the Sentry A6 MAX. We're going to put these 4 gate motors to the test. In order to compare these gate motors, I've set up an experiment. The experiment has 2 parts. The first part is called the light load. What I have is a setup where the gate is 150 kilograms and a calibrated continuous pull force of only 5 to 6 kilograms. We're then going to run the 4 gate motors sequentially to see how fast they can open the gate. Then we move to part 2. This is a heavy load. There you can see the weights on the gate. The gate is now 500 kilograms and the calibrated continuous pull force is between about 16 to 19 kilograms. We are then going to compare the 4 gate motors in terms of how fast they can open the gate. In order to do these tests, I use the industrial gate setup at Centurion Systems. To complete part 1 of the experiment, I needed to verify that the pull force along the travel was between about 5 and 6 kilograms, and then each motor was tested sequentially and the speed of the gate was measured. The results were recorded, and then we moved on to part 2 with a heavier gate, now 500 kilograms with a higher pull force, and the pull force was set between about 16 to 19 kilograms along the gate travel. For the heavy load test, I followed the same procedure, giving each motor an opportunity to run a few trials, and I measured the speed of the gate opening. The results were recorded. In order to conduct these tests, I needed a test rig. I used the test rig at Centurion Systems, however this is not a sponsored video. Centurion Systems have an elaborate test rig which I'm now going to demonstrate.
What we are looking at here is our test rig used for testing sliding gate motors. It has an orange frame and these blue sliding gates on the frame. The gates have cables on the end to allow the pull force to be adjusted. Weights can also be added to the gates, adjusting their mass between 150 and 600 kilograms. This is an example of one of the gates on the test rig. So what we have here is 2 gates connected via a cable which runs over 2 pulleys. The top gate has a DC motor connected to a variable power supply. This allows us to get a constant speed on the gates when measuring the pull force. We have a variable DC power supply connected to a DC motor over here, which allows us to get a constant speed on the top gate, which is doing the pulling. The 2 gates are connected by the steel cable, which runs over 2 pulleys. In line with the cable, we have an electronic crane scale, which gives us a digital readout of the pull force required to move the gate. The top gate is connected to the lower gate with a steel cable that runs over 2 pulleys.
In this setup, we're using the top gate to pull the bottom gate to measure the pull force along the travel.
On the left side of the lower gate, we have another cable which runs over 2 pulleys to some suspended weights. By adjusting the weights, we are accurately able to adjust the pull force required to move the gate.
In order to simulate varying gates with varying loads, we are able to do this by using weight plates. We set the gate to have a pull force of between 5 and 6 kilograms. To determine the continuous pull force, we use one gate, the top gate, to pull the middle gate, the gate under test. We measure the pull force along the travel. The gates move at a constant speed. Notice we've applied a small brake onto the roller. This is to reduce the effect of momentum. We've calibrated the correct weight plate in order to get a continuous pull force of between 5 and 6 kilograms. Using a tachometer, we measure the gate speed. Right, we are now going to test the 4 different motors. There is a platform here. We are going to mount the 4 different motors sequentially. Each gate motor has its own unique base plate. We are going to start with the Centurion D5 Smart. For each of the gate motors, we've got to confirm that the pinion and the rack have a little bit of free play. If the rack is resting directly on the pinion, it will increase the friction. In this case, we can see that there is some free play. Each of the gate motor models has been left on charge for a couple of hours. I'm just doing a measurement to confirm that the battery is charged. Currently, the unit is unplugged. That is the battery voltage. This is a fully charged battery. The D5 Smart uses 2 7 amp hour batteries. Both batteries are fully charged. We can gauge the motor to open the gate. This is the first trial for the Centurion D5 Smart. 34.6. Once the gate closed, we rerun the trial. 34.6. We then do a third trial and then take an average of all 3. Notice we run the trials immediately after the gate is closed. 34.7. Here are the specifications for the D5 Smart. The unit is designed for a maximum gate weight of 500 kilograms. The rated push force is 17 kilograms. Notice that the maximum motor push force at startup is 30 kilograms, and the reason for this is when the gate is stationary, to get it moving requires a higher push force. Once the gate is in motion, the push force reduces. The specification for the maximum gate speed is up to 35 meters per minute at a rated push force of 17 kilograms. Here are the results which were measured. This is for part 1, the lightly loaded setup. The gate mass was 150 kilograms, and remember, the push force was 5 to 6 kilograms along the path. This is not the maximum push force, this is the continuous push force along the travel. The 3 trials were measured as follows. The average was 34.6 meters per minute. This is very close to the advertised maximum speed of the unit. The percentage difference is just over 1%, meaning that the gate performed just below the advertised maximum speed. There are many reasons for why a gate motor will not reach its maximum speed. In the specifications, you might notice that there is a disclaimer about the maximum speed. It does say that it does depend on load and other factors. As a brand new motor gets used more, the gears bed nicely and the lubricant thins out, and the motor actually operates at a slightly faster speed. We're now testing the Sentry A6 gate motor. The rack is also spaced away from the pinion to make sure there isn't an increase in friction. And now we have unplugged it, and there is the battery voltage showing a charged battery. For each of the gate motors, we try and get it to the maximum speed. $23.9. 24.0. The important specifications for the A6 MAX are as follows. The maximum gate mass, you can see it's 600 kilograms, and then the maximum push force is 30, but the rated or continuous push force is 20. The maximum gate speed is 28 to 30 meters per minute. It does say it varies with load, as do the other manufacturers also have a disclaimer about the maximum gate speed. Alright, the results for the Sentry A6 MAX for the lightly loaded test. The average speed of the gate opening was 24 meters per minute. That is quite a bit lower than the advertised speed, which was 30. So we can see that the percentage difference is just over 22% lower than the advertised. This is the ET.Nice. This unit is supplied with its own battery, which we have charged. It is unplugged, and the battery voltage at the moment is 13.6 volts. The rack and the pinion are checked that there is sufficient spacing along the path. Overload setting to maximum. Test 1. $25.2. 23.8. 23.8. The specifications for the Drive 500 are as follows. The maximum gate mass is 500 kilograms. Then the rated gate load is 18 kilograms, which I take as the continuous gate push force. There isn't a maximum push force provided. And then the rated gate speed is 28 meters per minute, also with a disclaimer saying that this rated speed is dependent on factors such as gate load, battery status, mains voltage, etc. Right, the results for the lightly loaded test, we can see that the average speed for the Drive 500 was 24.3, while the advertised maximum speed was 28. So there was a percentage difference of 14.29% lower than what was advertised. This is the Gemini 12 volt, 12 amp hour, and we've also seated the rack a few millimeters away from the pinion. This unit is supplied with its own 12 amp hour battery. This battery has been charged for the whole morning. The charged battery voltage is 13.3 volts. The sensitivity for the control board is set to the minimum. This is trial 1. $19. 18.8, 18.7. The Gemini 12 amp hour DC slider gate motor has a maximum pull force of 33 kilograms, while the rated pull force or continuous pull force is 18 kilograms. The gate speed is 19 meters per minute. Unfortunately, I was unable to find the maximum gate weight for the Gemini system. The Gemini DC slider achieved an average gate speed of 18.8 across the 3 trials. The advertised maximum speed is 19, so the percentage difference is just 0.88. For the full load test, we need to weight the gate. So we have these 25 kilogram concrete blocks. We have 14 of the blocks measuring 350 kilograms. Remember, the gate itself is 150 kilograms. So collectively, we now have a 500 kilogram gate. Each concrete block weighs between 24 and about 25 kilograms. To increase the pull force, we have added 12.5 kilograms of weight. These weights are connected to a pulley. As the preloaded gate moves along the track, the pull force will be measured. And there we can see the pull force ranges from between about 16 to about 19 kilograms. In real life situations, the pull force does vary along the gate's travel. This could be because of a track that is worn out or slightly deformed, or maybe not quite in a perfectly horizontal position. The rollers might also be worn, there might be gravel along the path, and a variety of other reasons which influences the pull force along the travel. The gate speed was about 7 meters per minute. The calibration procedure is very similar to the one that we did for the light loading, except for the gate was weighted to 500 kilograms and we increased the pull force. We still used a little weight plate there to reduce the effects of momentum. For the heavy load test, we're starting with the Centurion D5 Smart. .0. 30.3. 30.3. The results for the heavy load test, where the gate mass was 500 kilograms and the continuous pull force was between 16 and 19 kilograms. The Centurion D5 Smart achieved a speed of 30.5 meters per minute. The percentage difference is 13.63. The unit is rated for a maximum continuous pull force of 17 kilograms and a gate mass of 500 kilograms, meaning that the unit was run at its maximum specifications. We're now testing the Sentry A6 MAX. 9.6. Right, while testing the first trial of the 500 kilogram gate, we were faced with the check gate connection, requesting us to wait 2 minutes for overload. What's it saying?
Tamper attempt.
Okay.
Controller overloaded.
10. After the controller alarmed, it automatically reduces its opening and closing speed from 30 meters per minute to 24. So we're going to now leave it at 24. Shucks. I was unable to get the controller to operate the gate at that pull force, so I've reduced the pull force by 5 kilograms. So the new pull force will be between 12 and 13 kilograms in the hope that the controller will now operate the gate fully. This is the third trial. The first two were unable to complete the trial. So we've reduced the weight by 5 kilograms. So it's now plus minus 12 to 13 kilogram force, and we're going to run it again. .6. This is trial number 4. 14.7. Just in case it was the battery that was causing this problem, we have tried an additional fully charged battery, and we are now going to run it one more time. All right, so we've still got the pull force set lower by 5 kilograms, but we're going to run it one more time. All right, with the change battery, we got 14.8, which is very similar to the previous trial. So we see that it is not the battery that had any impact in this measurement. Okay, this is just an additional attempt. We noticed that when the controller thinks it's overloaded, it reduces the speed by 6 meters per minute. So it went from 30 to 24. It still picked up an overload fault, and then it dropped it down to 18. We have reduced the weight plates. The force was about 17 and now it's gone down to about 12. So we're going to run one final test now. We have now put the speeds back to maximum with the force at just between 12 and 13 kilograms. The gate is still a 500 kilogram gate. Alright, so it did go faster now that we set the speed back to max. We're getting an opening of 17.7, but unfortunately the controller is alarming and it's asking us to wait 2 minutes. So unfortunately we cannot complete the test for the Sentry A6 MAX.
The Sentry A6 MAX requires a detailed explanation. For the heavy load test, it started to operate with a speed of 9.6 on the first trial and 10 on the second trial, but both these trials failed to open the gate and an alarm condition was activated, which required a 2-minute delay before we could operate the unit again. After waiting the full 2 minutes, it still failed to operate the gate fully. The unit is advertised for a maximum gate mass of 600, even though our gate mass was 500 kilograms. It is also rated for a maximum continuous pull force of 20 kilograms, even though the pull force for this test was between 16 and 19 kilograms. So what I decided to do was to reduce the pull force, and I reduced it to between 12 and 13 kilograms. I did leave the gate mass at 500 kilograms. Having done this, the unit did operate the gate fully. The speeds were 14.6, 14.7 and 14.8. I did change the battery to make sure there wasn't the battery that had reduced the speed. Having used the new battery, we got 14.8, which is pretty much similar to the 2 trials prior. So it wasn't the battery. I did notice that when the unit thinks it's overloaded, it reduces the speed of the gate. So I put that back to the maximum, which then did open the gate at 17.7, but failed to open the gate fully. So it actually got stuck shortly after opening, so I could not count that as a full trial. So therefore the maximum speed for the lower pull force was 14.7. So that's a 68.46% difference from the advertised maximum speed of 30 meters per minute. Keeping in mind that this is at the lower continuous pull force because I was unable to get the unit to operate at the pull force we used for the other motors. We're now testing the ET.Nice Drive 500.
$20.1. 19.3, 19.5. To confirm the result, we are changing the battery with a fully charged battery and running the test one more time. 19.7.
For the ET.Nice, it was able to work at the continuous pull force of 16 to 19 kilograms, and the unit is rated for a maximum continuous pull force of 18 kilograms, and we successfully achieved a result of 19.7 for the average of the 3 trials. This, however, is a percentage speed difference of 35.05% because the advertised maximum speed is 28 meters per minute. Just to make sure that it wasn't the battery that was slowing the unit down, I did use a newly charged battery, and with the newly charged battery we can see that it didn't really make any impact to the speed of the gate moving.
For our last test, we're testing the Gemini 12V 12 amp hour gate motor. 15.8. 15.0. 15.0.
The Gemini gate motor was able to operate with the heavy load test with the gate mass of 500 and the continuous pull force of between 16 to 19 prior to starting the test. The average speed of the gate was 15.3 meters per minute. We do not know the advertised max gate mass, but the advertised speed was 19 meters per minute. Therefore, the percentage difference is 21.79%. The unit does have a specification for a maximum continuous pull force of 18 kilograms. On this page I have a graphical view of the 4 units in the order that they were tested. On the horizontal graph axis I have the gate speed in meters per minute. For each of the 4 units there are 3 plots. The green plot represents the advertised maximum speed. The blue plot represents the results for the part 1 or the light load. The red plot represents part 2 or the high load. For the Sentry A6 MAX I was unable to get the high load results, so I have a plot just for the medium load results. In the case of the Centurion D5 Smart, the advertised maximum speed was 35 meters per minute. Under light load conditions, it was quite close to the advertised maximum speed. Under the high load conditions, there was a percentage difference of 13.6% lower than the advertised maximum speed. Since this is a speed test, it is clear that the Centurion is the fastest, and that is why I awarded the first place. The ET.Nice Drive 500 has an advertised maximum speed of 28 meters per minute. Under lightly loaded conditions, we achieved a speed of 24.3 meters per minute. Under the high load conditions, the average opening speed was 19.7 meters per minute, which represents a 35% difference from what was advertised. It is for this reason that I give this the second place. The Gemini DC slider has an advertised maximum speed of only 19 meters per minute. However, under the light load conditions, it pretty much met that specification with an 18.8 meters per minute. Under the high load test, it achieved 15.3. It is for that reason that I awarded the third place. Under the lightly loaded test, the Sentry A6 MAX achieved 24 meters per minute. For the medium load test at 12 to 13 kilogram push force, it only achieved 14.7 meters per minute, which is a 68.5 percentage difference from the advertised maximum speed, and is for that reason that it comes in fourth. Thanks for watching, and cheers.